finish out today is the last bit of 6-7. That'll get us into the graphing tomorrow. The small modeling portion of it on Friday. And then we're basically done with what I want to get through with the polynomials for now. There will be other modeling parts that we're going to continue with, but we'll do that after our test. With that being said, what I've decided to go and do is we're going to finish 6-7 today. We're going to do 6-8 tomorrow on Thursday. We're going to do parts of the 6-9 stuff, and that's writing and giving a graph. And then on Monday, what we're going to do is the first 30 minutes of it, we're going to do some review stuff. And then the last 15 minutes, you'll have a non-calculator part. And then on Tuesday will be your full test. Okay? Now, when it comes down to the non-calculator portion, it would probably be something along the lines where I'm going to give you like a 5th degree polynomial or a 6th degree polynomial, and you'll have to find all your possible zeros. You just don't use calculator. Yes, ma'am?
So, like, that first, 30 minutes, are we going to be doing, some, review?
Yeah.
I'm going to go on the calculator part, so you just said we find all the possible ones you're going to have, let's go factor to find the actual ones.
It depends on what the instructions ask you to do. Yes, sir.
A little off topic. Next Thursday is that half day, right?
I don't think so.
No, we have a full week.
We actually have a full week of school. I know. Yeah, we don't have any, and there is no other halves or anything. So we just have a full week and then 2 days, and we have Thanksgiving stuff. All right.
Wait, so that Tuesday is
A regular Tuesday.
and then it's the week before Thanksgiving.
Oh, all right, so that's
So let's finish out 6-7. So what we're going to do here now is we're going to write the function, the polynomial function, with the given zeros. And you guys have been doing this. You've been working through this all along. For example, if I give you the following zeros, if I give you those as the zeros, what are the terms?
X minus 2, x plus 3, x minus 5. Look at me.
Now, if you did that, then what do you think you'd have to do? Multiply it out. So what we're doing is we're just multiplying things out. So you went with x squared plus x minus 6 times x minus 5. You just keep distributing through. We're working backwards today. So the function, polynomial function with those 3 zeros would be x cubed minus 4x squared minus 11x plus 30. You have 3 zeros, which means you're going to have what degree? Third degree polynomial.
That's so much fun.
Okay? You're working backwards. And the whole idea that this becomes pretty easy is because if you think about the number of times that we came up with the 0, what was the next thing I always asked you? What's the term? Whenever we had a term, I'd ask you, what's its 0? You knew going forward and backwards on these things relatively easy. What's wrong? Did I screw up?
What did you do with those first 2 questions?
I FOILed it out. X squared, x minus 2 and x plus 3 becomes x squared plus x minus 6. When you FOIL it, I just shortcutted it.
Oh, yeah.
Because negative 2 plus 3. Yeah, so one same thing. Okay. So obviously this is relatively easy. What comes into play though is when you see the following. You're in for a treat, right? Now here's what I want you to think. What's the degree of this polynomial? So give me a third degree polynomial. What are these are your 3 zeros. If these are your 3 zeros, that means your terms are going to be, well, it's going to be f of x is going to equal x minus 2, x plus I, x minus I. No, you're thinking of...
Wait, but x plus I and x minus I are the difference in squares. then x minus I, or x squared minus I squared.
Which is?
Plus 1.
Very good.
Yeah. Give me a second to think about
I
it.
kind of like,
What you recognize right off the bat, guys, what you recognize right off the bat there is that she had a difference of squares. X plus I, x minus I. So you wind up with x squared minus I squared. I squared is -1, so x minus -1 is, or excuse me, x squared minus -1 is x squared plus 1. And Christian, what you were talking about when you were showing me your stuff earlier, remember how you wanted the x squared plus 5? It was always plus or minus 5i or things. Oh yeah, x squared plus 25, so it's plus or minus 5i, or x squared plus 1 is plus or minus I. Here it is going backwards. So you were doing that already in your head, and you were getting it right. Okay? So now, lastly, then all I have to do is just FOIL it out. X squared, or excuse me, x cubed minus 2x squared, excuse me, plus x minus 2. Is that right?
Yeah.
Yeah. So your function is that.
Oh, that's fun.
yay!
Yes, ma'am.
I have a question. It slipped my mind, but I squared is -1, right?
I squared, I is the square root of -1. I squared is -1.
Okay.
Okay?
Oh, it said negative I squared plus.
Yeah, minus I squared well comes plus. Okay? So it's not that, yeah.
Not that like for this we would need to, but is there a way to put like I into your calculator?
No, it doesn't clear, it isn't, for something like this, it doesn't work. But if you did have stuff, remember when we did the adding and subtracting of i's?
That was
I didn't know that was a long time ago.
I remember.
It works on that, but it won't work when you FOIL. Okay. So the other weird thing here is when it looks like this then. Sometimes they'll have this. Well, let's see, your zeros are -3, 4. And then sometimes they just write -I. Now, what I want you to remember is in order to get an imaginary number, you had to have like x squared plus something to get a 0, right? So the book likes to make you think about it for a second. If they list the -I, what do you have to assume is already there also? Positive. You have to always assume that this is there also. You have to put that in. Because I will only show up if it's plus or minus.
So is it the same thing if they only do the positive I, then you have to do?
Correct. Yeah, if they give you just the positive I, that means that the -I has to be there as well. Okay?
They're always there.
They both have to be, they have to come in tandem if you will. There has to be a plus and minus. Yeah.
Sure, there's.
So if it like is like -3, 4, and -3i,
Then
then
there
we
has-
put positive 3i.
Correct. Correct. So when you get into something like this, you'll probably start to pick up on the idea that when you have a negative and a positive I, it's just x squared plus 1. You remember that?
Yeah.
It's always going to be x squared plus 1. And then here you'll have x plus 3, x minus 4. And it's just a matter of foiling and putting things together. X squared minus x minus 12 times x squared plus 1. And then you just finish it out with your function of x. X to the 4th minus x cubed minus 11x squared minus x minus 12. Then you're done. Okay?
Yay!
Yay! Math. Okay.
I like it when it's
Yes, sir.
Wait, why would it be x squared plus 1?
It's just life.
When you have I and negative I, it's x minus I, x plus I. If you FOIL that out, you get x squared minus xi plus xi minus I squared. X squared minus I squared, which is x squared plus 1. That's
Oh, that's fun.
So let's get it a little bit weirder.
So
So your zeros are -2, 5, -4i, and so.
Tack on a
just
4i.
positive I and 4I?
Yeah, and that's what you're saying too? Yeah. Notice in this case, I gave you just the -4i, which means what has to be there also?
Positive 4i.
Positive 4i. Yep. So the positive 4i has to be there. This is one of the things the book does quite often.
X squared plus 4.
What is that going to be?
Plus 16.
It's plus 16, isn't it?
Regular square.
This is x squared plus 16.
So plus 4 squared.
Well, if you think about it, you subtract 16 and take the square root, you get plus minus 4i, right?
Right.
That's how you get those quickly off the top of your head. And then here you just have x plus 2, x minus 5, and that part's easy. I don't need to show you the rest of that, right?
No.
All right. Now, let's throw the ultimate curveball then. What happens when they do this?
That's when you try.
Yes, sir.
Say they just gave us 3 minus I, would you assume there's?
Yes. Yep. Very good. Yeah. Whenever you see a any of the like the I stuff, there has to be a plus and a minus one. Yes, sir.
So for elimination, do you just plug it in?
Exactly. So in this case here, what do I have to also tack in?
Negative 5i.
The negative 5i has to go in.
Oh, and then you multiply.
So with the 5i and the negative 5i, what's its term?
X squared plus 25.
Good. Good. We know that this grouping here is going to get us an x squared plus 25. We know that, right?
Yeah.
Okay. Now the other side, remember what we were doing. If your zeros, excuse me, if my zeros were -2 and 5, it was x plus 2, x minus 5. Now my 0 is 3 minus I, so it's x minus 3 minus I. And then x minus 3 plus I.
I never know when to use brackets.
Use brackets after parentheses.
Yeah.
Now, that looks pretty awful, right?
I don't like this.
Okay.
I like it.
Here's what I want to do. Does everybody agree that it's x minus something on both of those?
Yeah.
Let's distribute the -1 to the parentheses.
Oh, that's smart. So then you get 5. No.
You okay with that?
Yeah.
And then we have, we okay with that?
Yeah.
Let me ask you this. Is there any rule that you can think of that says you cannot do that?
No.
No.
Wait, so then you can group them.
Hold on.
Or can't you?
Slow down for a second. I'm going to use something called U substitution.
What?
U substitution is when you're going to simplify an algebraic statement that looks god-awful with something that looks easier so you get the idea of what's happening. Here's what happens. I'm going to let U equal x minus 3. It can be x, it can be anything. It's just generally used, it's usually called U substitution. They do this more in pre-calc and calculus. Okay. So all I'm doing here is simplifying a complex algebraic statement with something that looks easier, and you should pick up on it right away. Now, if I let U equal the quantity x minus 3, I get U plus I and U minus I, which is what?
Oh, this is
It's a difference of squared. It's U squared,
minus.
I squared.
Oh, so then you can do,
So this is u squared minus I squared.
which is u squared plus 1.
Very good, which is u squared plus 1. Now, what was u equal to?
X minus 3.
So that is x minus 3 quantity squared plus 1.
I feel like that's like cheating the system.
It is, but all you're doing is you're making it work easier for you. Because in essence, you can do it both ways. You could sit there and you could FOIL that here. If you FOIL that out, you get x minus 3 quantity squared minus I times x minus 3 plus I x minus 3 minus I squared. You get the same result because what happens to your two middle terms? They drop out. And you get the same thing down here. Yes, sir?
What you call the U?
It's called U substitution. Okay? It's an algebraic trick that you're going to use probably second semester of pre-calc when you start talking about derivatives, when you get into the large formulas for solving for those, and it also again in calculus. They use U substitution quite a bit. Your brother's probably doing it right now. Okay? So what I'm just showing you here is how they're coming up with this god-awful looking thing, something that's really easy to do. Yes, ma'am?
So does x minus 3 quantity squared plus 1 substitute for that?
Yeah. So all I have to do now is just finish this out. When I take the quantity x minus 3 squared, I get x squared minus 6x plus 9 plus 1. So that's x squared minus 6x plus 10. And what do I have to multiply that against? Well, we had way up here a long time ago.
X squared plus 25.
Wow. Feels like ages ago.
It was like ages ago.
Wait, and then can you,
Let's do last year.
And then you just FOIL all that out. Because remember, you have four zeros, so you have a 4-3 polynomial.
oh, all right, so you
Well, we did the easy one first. We're just working through all the complex now. So you have x to the 4th minus 6x cubed plus 10x squared. How many quarters are 6 quarters?
150.
There you go.
That's a good one. That was nice.
Anytime you can think of it in terms of money, it's money.
Oh, yeah, because 4 of them is $1 and 2 more is
Wow.
Oh, like, really?
Wow! SMRT!
You forgot the A.
Not so.
Claire, remember when that was so
When I made that great joke and I got a point.
you,
I don't remember. That was like 4 years ago. So.
What was the joke?
it was like,
He said that, and then I was like, it's funny because I don't have an A in this class either.
That's right. I forgot about that joke. That was good. That was very good.
You gave me a point for it. You
I
put
did.
Claire plus 1 on the board.
Because that was very, I forgot about that.
Claire plus 1.
It's like you like have reservations. You're going to a wedding. It's Claire plus 1. You what?
I thought that was
Usually that's what happens.
I feel like if my sister ever gets married, she just
Alright. So I want you to try one. I'm giving you these two zeros, which means what?
There's 2
4
more.
plus I.
There's what's missing?
The 6I and 4 plus I.
Good. Write out the polynomial for me. Take a couple of There's only so many of these things you can come up with without duplicating the ones you're going to have in your homework. So we know we have 4 minus I, 4 plus I, plus or minus 6I, which gives you x squared plus 36. We're okay with that part, right?
Yeah.
Now, when you go into the grouping here, you have the x minus 4 minus I. Then you have x minus the 4 plus I. So it's x minus 4 plus I. X minus 4 minus I. Now, if you're using that U substitution, You can go right ahead and say let u equal x minus 4. I'm just going to start shortcutting it. Because it's going to be the same pattern every time. You're just going to get x minus 4 quantity squared minus 1. That's going to happen.
Wait, minus 1.
I didn't plus.
Oh, wait, no, sorry. It's minus and negative 1, so yes, it's plus 1. Sorry. Sorry. Thank you.
I was like,
Hey, this is what happens when you're home with sick kids. You forget how to do math.
What? That happens to me when I'm not. What happens when I'm
So here we have x squared minus 8x plus 16 plus 1 times the x squared plus 36. Let's see, so your f of x is going to equal x to the 4th minus 8x cubed, 17x squared, 36x squared minus would be 72, 144, 288. How do I know what?
how'd you do that so quickly?
All right, this is 8 is 4 2's, right? Double it. Double it again, that's times 4. Double that's times 8. Double 36 is 72. Double that's 144, so that's 36 times 4. Double that again, you have 288, that's times 8.
36 times 10 minus
Still really quick.
I got the skills! Now, 17 and 36 is going to be something I have no stinking clue, but I bet you it ends in a 8. How much?
12.
I thought it was.
Oh, I'm thinking 8 times 6. It's
7 times
6.
6 is 42.
I never said I was really good at math. And then just combine them out, so your f of x. Good. This would have been an awful one to factor, wouldn't it?
Yes.
You'd have to go. Well, you'd have to list all your tails of 6, 12. I mean, it would take you have what would have been 1, 2, 3, 4, then 6. You'd have to go through plus or minus 1, plus or minus 2, plus or minus 3, plus or minus. You had to go actually because these all had imaginary. None of your reals would have worked at all. You guys would have been swearing at me a lot. With the square term, yeah.
That's my go-to method.
No, that won't work. Let's do this then. So this is still section 6.7. It's page 370. I'd like you to do numbers. I'd like you to do those, please. Just you're writing out the function given a specific amount of zeros. Okay? It's a pretty good quick mix. It shouldn't take you very long to go through them. So we'll go over this briefly tomorrow, then we'll start talking about how we plot and graph. Make sure you've got your calculators tomorrow because we're going to talk about what our local maximums and local minimums are, how you find them, and build out of that. Friday, along with the modeling that we're going to do, we're going to do some of the word problems in the chapter. The word problems in this chapter, once again, is nothing more than using your table function in the calculator to be able to find the specific values. Okay? You're going to have to get better at them. You can't just say, I hate them.
I can't do that.
Yes, you can.
I don't know if you've noticed, but every time.
Jimmy has 8 apples and he sold 3. How many apples does he have left? You did it. Congratulations.
But like every time we've done a word problem, like question in this class, I've gotten it wrong.
Well,
I haven't gotten a single word problem right in this class.
Mr. Murphy, I think it may even have to do with
Pretty sure that's why I had